Hello doctor, we are from Group B and we in charge of larger grave tablets B. Our group consists of 4 members, AHMAD, FAKHRUL, Wong, Siong, Cheng, AISYAH and BENEDIC. I'm Wong and I'm going to present the first part of this assignment. We are given 200 sample data based on 3 characteristics, the weight, reactive density and tensile strength, and it consists of 3 different shifts, the morning shift, evening shift and also the night shift. First of all, we use the pivot table to extract the data based on the shift, morning shift, evening shift, the night shift. After that, we use the formula inside the Excel to count the sample size for each shift and also find the value for maximum value, minimum value, and also the variance value and also the other value. After that, we choose several values to represent it in graphs according to the 3 characteristics of the tablet. That is the weight, tensile strength, and reactive density. For the analysis report on the distribution of the data set, we can observe that for the tablet weight, the variance value, the evening shift has the highest variance value if compared to the morning shift and also the night shift. For the reactive density of the tablet, the evening shift also has the highest variance value, and same goes to the tensile strength. The evening shift also has the highest variance value. Besides that, we can also observe that the variance value for the weight productions for each shift is actually higher if compared to the reactive density, which all less than 5, and tensile strength all less than 1. In conclusion, the manufacturer should be more concerned about the consistency of tablet weight production and also the evening shift production. This is because the higher the variance value, that means the data set is much different from the sample mean. That's all from me.
Assalamualaikum. My name is AHMAD FAKHRULROZZI and now I want to explain about task B. Based on given question, we need to comment whether there is a significant evidence that lajak laku tablet produced in December 2020 and we need to follow this distribution. Before that, we need to create a frequency table with table range by using the data given. So next, by using Microsoft Excel, we are able to find the value of frequency with suitable range. The data was collected from less than 310 until greater than 390. By using the equation, we are able to find the value of probability, and the sum of all the value is 1. Next is hypothesis. H0 will be the weight of the standard tablet produced by manufacturer follow normal distribution. And for H1, the weight of standard tablet produced by manufacturer does not follow the normal distribution. The given value of mean and standard deviation was 350 and 14 respectively. After that, we will continue with test statistic. By using the given question, we are able to find the value of expected frequency. Since the value of expected frequency for observed frequency 1 and 5 does not equal or higher than 5, so we need to combine with net value, which is the value of frequency 6. Same goes to observed frequency 3 and 1. We need to combine with the value frequency 11 to get expected frequency greater than 5. By sum of all value in next table, we will get the value of x squared test. Next is decision rule. With seed number of row and no parameter estimated, we are able to get the value of degree of freedom, which is 5, and found the critical value is 11.0705. The decision is will we reject H0 if x squared test greater than critical value. Lastly is conclusion. Since the value of x squared test is equal to 2.0113 less than critical value, which is equal to 11.0705, then we fail to reject H0. Therefore, we conclude that the data is following the normal distribution based on requirement with 350 mg mean and 40 mg standard deviation at alpha equal to 0.05.
Thank you to the previous presenter. Now I am going to show how to solve the question Z. In order to answer this question, you have to use the hypothesis testing, which is the ANOVA method. So from the table given, we only have to use the column which is the weight and also the shift. Since there is different shifts, so that means the shift is the factor. So we're gonna let morning is equals to 1, evening equals to 2, and night equal to 3. Since there is 3 different shifts, so that means the number of factor is equals to 3. In this analysis, we are going to use the alpha is equals to 0.05. Since we are using the ANOVA method, the hypothesis H0 is mu1 equals to mu2 equals to mu3. H1 is mu I is not equals to mu j, for at least one of the I and j is not equal. this is a table that we obtained from the Excel. From the summary table, count here is equivalent to the number of samples of each shift. This is the sum, average, variance of each shift. From the ANOVA table, the between groups is the treatment and within groups is the error. SS here is to indicate the sum of squares. DF here is the degree of freedom. 2 here is to indicate V1, which is K minus 1. For 197 here is V2, which is N minus K. MS if the mean of squares. While F here is the F test. P-value is P-value. F-crit is the critical point. The decision rule for ANOVA method is critical point is equivalent to F alpha V1 V2, which is equals to F 0.05 to 197, which is equivalent to 3.0418, which is the number of F-crit but in 4 decimal point. The condition here in the decision rule is reject hash knot if F-test is much larger than the critical point. The conclusion, since F-test equals to 0.4235 is much smaller than critical point, which is 3.0418. Therefore, it is failed to reject hash knot. We can conclude that there is no significant difference in tablets in weight in mg from different shift at alpha equals to 0.05.
Greetings, my name is Benedic. I will present the last question, which is question D. From the data given, we can plot a scatter diagram as shown. Then, we can make data analysis from Microsoft Excel and obtain the following summary of regression model. In this regression model summary, we can get the values of the intercept and relative density. From the table, we can get equation of regression model as here, y equals to 0.0825886x minus 0.17248. And then we can plot the regression model of y versus x as here. The red line is the average of tensile strength. Therefore, we can predict the strength, the tensile strength as the table shown here. At percentage 68.0, we can approximate the tensile strength is 5.4433680. At 74.3%, 5.9636598. While at 80.1%, the approximation of tensile strength is 6.4426586. To validate the regression model, we can assume the following. The errors are normally distributed. The mean of random errors is 0. Variance of random errors is an unknown constant. And the errors are uncorrelated. So we can carry out 3 tests, which is linearity test, homoscedasticity test, and normality test. Firstly, the linearity test. We test at alpha equals to 0.05. First, the hypothesis we make is beta equals to 0 and beta not equals to 0. Next is test statistic. We can get the p-value, the t-stat, and f from the table that we get from here. The p-value, t-stat, and f. So, we proceed to the decision rule. The decision rule we can get from statistical table. So, from statistical table, we can get the value of f is 3.84. So, if f is greater than 3.84, we can reject hash knot. While when we get t from t equals to 1.960 from statistical table. Therefore, if t-stat is greater than 1.960, we can reject hash knot. Also, p-value. If p-value is less than alpha equals to 0.05, we can reject hash knot as well. So finally, based on the values we get, we can conclude that there is a significant relationship and linear relationship present between the relative density and tensile strength at alpha equals to 0.05. Next is homoscedasticity test. Now, this is the test, the model, whether the model have constant error variance. So, we can plot as shown here. We can get this from Microsoft Excel as well, using the data analysis. So, in this plot, in this graph, the red line is about constant 0 and no outliers present. So, this mean of the mean of error is 0 and variance of errors are constant. For the last test is normality test. For the normality test, this is to test the errors are normally distributed or not. Also, we can get the normal probability plot from data analysis by using Microsoft Excel. If the data is normally distributed, it will show a graph with linear properties. So in this graph, it is shown that this shows linear property as shown here. Therefore, the residuals here is normally distributed. For the last and conclusion we can make is the model satisfies all assumptions. So this model is valid. Thank you.